Lesson 15, Comparing Datasets. Learning target, I can compare and contrast situations using measures of center and measures of variability. We will be talking about comparing datasets in this lesson. Before we go over an example, let's zoom out for a moment and think about which measures should be used to compare based on what type of graph we have. We're going to be talking about two types of distributions. The shape of the distribution, either symmetric distributions or skewed distributions, and distributions with outliers determine which measure of center and measure of variability should be used. Let's start by looking at the measures of center. When there's a symmetric distribution, the mean should be used to compare. And when there's a skewed distribution, or a distribution with outliers, the median should be used. In symmetric distributions, the mean is equal to the median, but the mean is preferred because it is calculated with all the values in the dataset. But in a skewed distribution, or those with outliers, the median more accurately represents the center. Data values farther from the center impact the median less than the mean, so the median remains near the typical values. Now let's look at which measures of variability to use. When there's a symmetric distribution, the standard deviation should be used to compare. And when there's a skewed distribution, the interquartile range, or IQR, should be used. The data set with the higher measure of variability is more variable. How do we estimate variability? Estimate the center, and then estimate how spread apart the data is. Let's look at a few dot plots to practice estimating the variability level. This set of data represents the annual income of individuals in a city. As we can see, the data points, the yearly incomes, are pretty spread out far from the center point. So this dot plot has high variability. The annual income in this city has a very high variability. This second set of data represents the daily temperatures in a city. As we can see, the data points, the temperatures, are also spread out far from the center point. So this dot plot has high variability as well. The city has a high variability of temperatures. This set of data represents test scores in the class. The data points, the test scores, are not nearly as spread out as the other data sets we've looked at. The data points are all pretty close to the center value. 84 on one end, 88 on the other end. So this plot has low variability. The test scores do not vary that much. Let's get into an example. Which measure of center or measure of variability should be used to compare the number of seconds it takes football players to complete a 40-yard dash at two different positions? Here are dot plots of both sets of data. We've got wide receivers and we've got tight ends. The tight ends' times do not seem symmetric, so we should find the median and the IQR to compare the information. Let's compare using the median and the IQR. We can either compute the measures or look at the box plots below. We'll use these box plots to determine the median and the IQR. Let's start with the median. From the box plot, we can see that the wide receivers have a median of 4 5/10 seconds, and the tight ends have a median of 4 9/10 seconds. Tight ends, wide receivers. The tight ends have a greater median. Now let's move on to the IQR. The wide receivers have an IQR of 0 and 2500 seconds. And the tight ends have an IQR of 0 and 5/10 seconds. The tight ends have a greater IQR. We know that the tight ends have a greater median and a greater IQR. But what does this mean? This means that the tight ends tend to be slower in the 40-yard dash when compared to the wide receivers. The tight ends also have greater variability in their times. Together, this can be taken to mean that, in general, a typical wide receiver is faster than a typical tight end, and the wide receivers tend to have more similar times to one another than the tight ends do to one another.